This is vlog entry 135, and it's about noon. Been a little bit busy. I decided not to record yesterday. It wasn't really me making a decision on whether to record. I was just so sidetracked with other things I didn't really bother. So I guess it was partially a decision, but it wasn't premeditated at all. Yeah, I've been just busy. I spent time with my friend. We hung out. We had a little fire. It's one of the last warm nights of the season. I was beside the lake and it was nice, and we had a nice skyline. It was enjoyable. I don't know. I'm not really a big fan of going to crowded places, so I don't like going to bars or big events or concerts or loud places. I don't like loud places much. I can't think straight when I'm around a lot of people and loud noises. So I'd prefer to be out in a park somewhere with a fire, away from all of the noise. Yeah. But the only reason I moved to a city is because I also want to be around a lot of people, which is a little bit contradictory to some extent, but I just like seeing faces, I guess. It's a huge variety of faces in a city, so it's nice. It's fun. I also like people watching, and I can just people watch for my apartment, so that's also nice. A life update. I haven't really done much, except I've been more focused on my body, and I'm trying to find that nice balance for the given state that I'm in right now. It's going to be really hard to juggle working, taking care of my body, and also still focusing on my interests that happen to be situated around physics. Although it may look a little bit turbulent and chaotic when it comes to my approach towards physics, I believe it's worthwhile. I've been listening to my inner voice more, and it's been telling me that this is a worthwhile endeavor. This has happened to me multiple. The first time it ever really happened to me, where I actually started listening to my inner voice, is when I moved here. Now, from the outside, again, it seemed like one of those things that didn't seem logical, but it happened to have ended up being a very profitable thing. It's kind of hard for the mind to wrap its head around certain actions that the inner voice or the intuition thinks is best for itself at that given time. So I decided to silence my mind and listen to my voice, my inner voice. Kind of doing the same thing here. Of course, I can't just completely silence my mind because I am dealing with highly abstract concepts, but I believe that this endeavor is supposed to happen. Just because I happen to be somewhat talented when it comes to physics and dealing with abstractions in my mind, and I enjoyed it a lot. It was fulfilling, and now it feels more like a project / mission, because I'm trying to understand all of these, and I'm trying to tie it into a framework of some sort. I don't know what kind of framework I'm trying to build. Of course, I'm just kind of moving. And as it happens, I'm typically not the kind of person to jump into something without knowing all the variables, but I'm doing it now, and I'm just going to keep pushing forward in some direction when it comes to physics for the time being. And also, I was thinking about I've changed my reality once. I remember a year ago, I envisioned this reality that I'm in right now just a year ago. Well, maybe more like a month. Yeah. When did I start? I guess that's when I quit my job. That was back in September. A year and 2 months would be it was basically the time. Again, it was more of a form of dissatisfaction. I felt like I wasn't really moving forward anywhere. And yeah, sure, I had my hobbies, and I have happened to have been programming and enjoying the abstractions of my world. But also, I kind of wanted to change the scenery to a degree. I was tired of having a car because I don't like cars, I guess. And it was just dull. It felt dull, so I wanted to try something different. And now this reality that I've created is satisfying. But the mind, especially when you're out of survival mode, likes to evolve in particular directions. It has to. I mean, that's the whole point of life itself, is to evolve to some extent. I guess I'm trying to apply that principle more in my life, and it works out pretty well. It's just when you're evolving, you should have at least a general direction which you're going. You know, a North Star. And I'm trying to find a new North Star. I guess is the best way to say it. My North Star a year and 2 months ago was trying out a normal life, and then realizing that a normal life isn't really what I want. I thought maybe if I tried out having a normal life, I'd understand why everybody else likes it so much, but um, it doesn't feel satisfying to me. So I guess for me, I am more of a path forger. I don't know what I'd call it, just somebody that can't quite fit into the cookie cutter mold, the molds of what a typical life should be like. And of course, I get a lot of backlash from my family, thinking that they know what's best for me, but I think they're slowly learning that I'm actually much happier than I was before when I was in school, and even after I dropped out of school. They're learning to just let me do my own thing and to just do my own thing, I guess. To trust me and what I think is best for me, myself, and all that. Although they are saying, yeah, it probably is logical to finish that last year of school, but even there's still a part of me that's saying you don't have to do that. There's something else in store for you. I don't know where it's coming from. I can't quite put my finger on it, and I'm not sure if that voice is coming from due to my preferences or if it's an actual inherent truth that I happen to not see as of now. If that kind of makes sense, you know what I mean? I'm not sure if people have felt this before, but people like to call it the higher self. Well, not necessarily the higher self, but the intuition. I don't know. I guess the intuition is also an expression of the higher self to a degree. It's telling you where to go, and it happens to know because, from a spiritual perspective, it already knows because it already knows because it's already there, I guess would be the best way to say it. So, yeah, I'm using that as my guiding star for the time being, and I tend to just drop all of my worries because the world has already kind of formed itself around me, if that kind of makes sense. Everything that I've pretty much asked for came to me. Not really came to me, I had to. It's a balance, of course. It's not just you praying for something and it showing up. It happens to be double-sided thing, because for there to be harmony in the world, it can't just be one side of the coin. It has to be both. So the universe think of it as a macrocosm taking action also requires for the microcosm to take action to achieve harmony. Yeah. So it's just a principle that I've instilled into my own mind that I've just collected from experience. So recently, I was creating more maps. I had to keep on creating maps because I don't have clear picture in mind. I need a clear picture in mind because I don't want to get lost in the forest. It's easy to get lost in the forest when you get into these very complicated structures. And the last thing, I guess I have I have a map for physics, and I have a lot of trees and whatnot that I've created that involve what I should be kind of instilling a foundation under for general relativity and quantum mechanics, and until maybe something else kind of catches my mind that sparks inspiration within me to maybe create even more ideas out of it. But I've created a lot of ideas. It's just they're kind of everywhere, and it's hard to connect all of them into one big structure. So I guess that probably means that I need to do more research. I have a knowledge gap. I think for most people that would make sense, right? You have an idea. I don't know whether the idea is I want a car or something. It's shit, I have to do a particular series of things before I can get that car or whatever. Or if I want to do something, it's outside of you. The thing that's outside of me now is, basically employing a generating function and that generating function happens to employ a non-duality to an extent, and how non-duality can actually explain everything that I've seen in these mathematical frameworks, including the field equations that you can think of, like, classical field theory, and I'm looking at GR, and maybe this will serve as an explanation to somehow bind general relativity and quantum mechanics or quantum field theory. I just say quantum mechanics because quantum mechanics is a superset of quantum field theory, I believe. I could be wrong. It's an explanation. Quantum field theory is an explanation of quantum mechanics, right? It's just a different interpretation. You have quantum mechanics and then quantum classical. I guess we maybe call it just classical quantum mechanics, or classic. I don't know. There's also quantum physics, which is, I don't know. Anyways, maybe quantum mechanics and quantum field theory are both the explanations of quantum physics. I don't know how to map it in my head, but yeah. I've been looking at. I basically created branch points, and I'm looking at the basis for all of it, a generating function for all these things in my mind is not quite understanding completely, at least from a mathematical point of view, because I have more of an intuitive sense, but I don't have a deep understanding of the mathematical structures that are used in a lot of these things, like general relativity and quantum field theory. Canonical quantization requires you to somewhat understand Lagrangians to some extent, and I was looking into the mapping for Lagrangian mechanics because I have never taken a classical course in Lagrangian mechanics, and I looked at a couple of things. There's like something called the principle of least action. Well, there's least action. There's a principle of stationary action, if I remember correctly. Yes, principle of stationary action. And so, of course, if you've taken calculus of variations, you can do like an action curve, and then this action curve probably has a minimum and maximum. It could have multiple minimums or maximas, but these action curves tend to land on a minimum. This is why you have a principle for this, which is called the principle of least action. And so we analyze these curves, and you can actually derive Newton's motion from this supposed idea. And not only that, it's you can also derive Newton's equations of motion through the principle of stationary action. And by doing that, you can actually take the definition of action, which is actually the integral of the Lagrangian over time between 2 points t1 and t2, and you can do some fancy math, and it'll end out spitting out the equations of motion, which is kind of cool. Of course, Lagrangians are based off of generalized coordinates, but then you can call those generalized coordinates being like v, and standard Cartesian coordinates is the generalized coordinate that it's a manifestation of that. So, and then it just spits it out, which is, of course, we call it q, but then you would replace that with an x, and then boom, you have it ends out with, if I remember correctly, it ends out with ma on one side, force, of course, and so that's also m times dx over dt squared. Dt squared because it's you apply the dt operator twice on it to get acceleration, and also the other side is the potential function, the negative potential function with respect to x. Of course, you would actually replace that derivative with a del operator, which is just a triangle. It's an upward triangle, it's a downward triangle. The upward triangle is referring to incremental change, discrete change. So by looking at that upward triangle, I didn't mean to say that, but also that's a standard equation in classical mechanics. It says how force relates to the potential with respect to like an x, and now I don't have a good way of explaining that intuitively. I mean, if you go the opposite way of a potential, so if you change a potential with so if you have, like, I think probably the best way to think of this is that you have 2 points, right? You have x1, x2, and it would require more force to it for it to reach a particular potential if you change x. So if x goes lower, or sorry, if x goes higher, so if x goes up, u goes down. Why is that actually? That's interesting. I mean, I guess that would imply a constant force. So if there's a constant force applied to that, then obviously you don't the force applied to that particular object to reach a particular kinetic energy or potential energy. We call potential energy because it's a projection to with time. I guess would be a good way to think of it. Even though time and space are kind of the same thing, but whatever. We don't have to talk about that. I still call it space and time, but people call it space time, whatever. But whatever. So that's why it happens to be a negative. It's a well, yeah. I mean, it makes sense in my head. I had to think about that for a second, but it makes sense as I think about it. Yeah. I'm actually surprised that I can explain most of these things if I just give myself a second to try to think about it, which is nice. Yeah. That makes sense to me. Maybe it won't make sense to other people because of the way I explained it was a little bit iffy. But I mean, I have like this image in my head. So, but anyways, like, you know, I'm also being very abstract. I'm not even giving you an example. It's like a completely abstracted abstraction. It's just like, you know, anyways, completely abstract. You can think of like a force field, right? It's like, for it to hit a certain potential energy, so as the potential energy goes up, and the distance is the same, you don't change the distance, and obviously, there would have to be more force applied to it, right? Yeah. Or less force applied to it, my bad. And this is with respect to x. I'm thinking about time, but respect to x. So as x goes, anyways, I explained it already, and I just forgot my explanation of it. But yeah, yeah, it's kind of interesting. And so I was looking at that, and I was looking at Lagrangian mechanics, and I still haven't looked at the Hamiltonian, but I believe it's just the mechanical energy, but the Hamiltonian is a more abstracted, more general way of expressing total energy in a system, because it doesn't just apply to Newton's equations of motions. That happens to be one manifestation of the Hamiltonian. Hamiltonian also goes into quantum mechanics as well, and energy seems to be expressed differently in quantum mechanics. So you can't just call it standard mechanical energy from Newton's perspective, at least. So that's the reason why we call it the Hamiltonian as opposed to the mechanical energy. The Hamiltonian happens to be just a generalization of mechanical energy, and mechanical energy is just a very specific manifestation of the Hamiltonian, I believe. Let me see what Wikipedia says. Hamiltonian quantum mechanics. Yeah. Hamiltonian of a system is an operator. Of course, you have to think about an operator in mechanics because, I don't know the precise way. It's just how they explain it. But they think of it as an operator because you can, let's say, I don't know, you have a wave equation. Wave equation actually contains all the information pertaining to the energy, the momentum, and where certain particles exist. And so you can take it, that's why they call them operators, because you're operating on the wave equation, which is the wave equation in standard quantum mechanics is the whole state of a system, but in wave format, because everything is waves apparently nowadays. This is how we think of it. So that's why they call them operators. So that's why you have like an X operator. The X operator actually takes out the expected value, I believe. The expected value is nothing more than the mean of the wave. Oh, well, the wave squared, sorry, the mean of the wave squared, because you have to square to get a real number out of it and to have it normalized to then, be between 0 and 1. Yeah. And, it's, again, you also have to think about, like, the integral of that curve as well adds up to 1. Between, it's 0. Is it negative infinity to infinity? Or is it 0 to infinity? Does it start? I guess it'll be negative infinity, because, again, this curve just goes out ad infinitum in both sides, so it's negative infinity. So it's the integral from negative infinity to infinity of the normalized wave squared is equal to 1 with respect to dx in this case, because dx happens to be what we're analyzing in that situation. Same thing with momentum. The momentum operator tends to spit out the same thing, except it has a mass involved in. What is it like? What's it in standard quantum mechanics? It's like IH bar times like over 2m or something. Yeah. The 2m is just from, where's the 2m from? From the kinetic energy, must be. Why are they in the same denominator, though? Oh, because they're on the other side. Actually, no, that does make sense. They still wanted me to... I don't know, I had to think about that. So, yeah, I've understood most of the Lagrangian principles that, once you look at it from a high perspective, you can fill in the details with standard calculus variations, and you can rederive the equations of motion. And not only that, it happens to give a very compact equation relation or equivalence between the generalized coordinate and the, generalized coordinate and the energy, or the not the energy, potential energy. Sorry. Yeah. So now another interesting thing about these Lagrangian is that they always take a path of least action. You can see this in the real world because if you look at if you throw a ball up in the air, I mean, you can give a lot of examples, but I guess the easiest example would be just like throwing a ball and you get this parabola because it's dependent on t squared, so that's why you get that nice little parabola, and then, you're looking at xt. So yeah, that's why you get a nice little parabola. Wait, is that right? Yeah, because x is changing, because the x momentum is changing linearly. It looks like a parabola, even though it's with respect to time. Time would be kind of three-dimensional because we're looking at a two-dimensional graph of space, but whatever. Yeah, so this parabola happens to be a path of least action for that given system. And this is also really interesting, and seeing how this happens and why it does and why it happens to be the path of least action is also a ramification of, I don't know, I mean, I don't really, that's another principle that they call it like delta S is equal to 0, I guess, as path of least action. The change of action is equal to 0, and it probably just derives from stationary action, the principle of stationary action, which is what people talk about all the time in Lagrangian mechanics or classical mechanics. Lagrangian mechanics is still under classical mechanics just because we're not talking about quantum stuff. I also still have to look at harmonic oscillators, because that's another way of seeing these fields, is by seeing it as a series. As I think my definition is good enough because Hooke's constant, right? Hooke's constant actually is a tension factor, isn't it? Was F is equal to negative HK or something, or K something, KX, negative KX. Of course, if you take the X, as X goes down linearly, the force gets higher, and then also it happens to be linearly related to F, and then that constant is a tension, because as a constant gets higher and higher, then the tension is stronger, meaning that the force is going to get bigger as it scales. The slope of the relation between X and F tend to become higher because of the fact that the tension is higher. So now you can think of it as a tension. Same way that I thought of it. People are so silly sometimes. The way they think of it is just a series as harmonic oscillators of the mass, and it makes sense. Of course, you think I don't like thinking about springs because it's silly to think about springs. But I don't like, for some reason my brain doesn't like thinking about more contrived examples. I like thinking about that for whatever reason. But then it also can be confusing at times, because when you just speak in abstract terms and not really give a specific example or series of examples that explain it, it can be confusing. And that has happened to me before when I study mathematics, right? Mathematical structures is good to understand mathematical structures through a series of, not too many examples, maybe a couple of examples, and then it should sink in by then if you are somewhat, if you have an affinity towards, understanding abstract structures. Because the English itself can be confusing to explain it that way. English, I don't know. For me, I have trouble. I misinterpret English at times, or sometimes it's just the way that they write the definition of it. But yeah. So sometimes I don't know. I like being. I second guess myself as well. That happens to me when I talk to people. It's like, can you please be a little bit more specific so I know that I know exactly what you mean, as opposed to me guessing. I don't like guessing. I like precise language. So yeah. I mean, figurative languages can be fun at times to use. I like analogies as well. But when it comes to people using vague terminology, that's when it gets like, can you please be more specific? Please, I don't know. That's just me, I guess. I don't know. The other people are the same way, but I like precise language. So yeah, I have a pretty big mind map. I actually understand Lagrangian mechanics intuitively to some extent, but I don't necessarily understand the connection between, path of least action and why stationary. I guess no, sorry. I guess path of least. How do they actually find that? Actually, that's also very interesting. Like, how do they find that? I don't know. I guess you could probably take an example from a Newtonian perspective, and it seems like path of least action tends to occur in the world because of this. You can just understand that this parabola describes the action curve, I guess. I mean, there's an action curve. This means this action curve also manifests between different paths and whatnot. But this parabola directly maps to that minimum of the action curve. So that's why they call it the path of least action. Why? It seems like reality likes to do that. You can actually see that in light as well, which I don't feel like explaining. But if you see the reason why light refracts at certain angles is because it's a manifestation of the same principle of path of least action. It happens to be a minimum of the action curve, I guess. It's a minimum of the action curve, yeah. So I may look into action more and try to understand it more, because like the way that they have it still, I don't know, it kind of messes with my head just thinking about it. I think what's the Lagrange? I think it's k minus u. Is it k minus u or u minus k? Equation. Is it k minus u or u minus k? Or t, what is t? Oh, v is the, okay, so it's t is kinetic energy minus v, which is, okay, so it's kinetic minus potential. I have to remember that. I flip it in my head sometimes. But kinetic minus, you would think that it would be the other way around if they were subtracting, because the potential energy always has to be more than the kinetic energy. So you're adding a bunch of negatives. Does that sound weird? I don't know. Doesn't the kinetic energy always have to be less than the potential energy? Oh no, that's wrong actually. My bad. That's only in certain cases where like it's the kinetic energy is a quarter of the total mechanical energy, or less than. I guess the best way to say is less than half of the total mechanical energy. I don't know why my brain was thinking about that. Yeah, so it's interesting, I guess. I mean, it's interesting. Now that actually kind of makes sense to some degree. I mean, like, if you think about like a bar or something, this bar has in simple systems, you can think of like a force field or whatever. It's like it's a changing bar. So since it's symmetrical and it's changing between points at a constant rate, I guess would be a good way to say it, ends out being zero. Because you get the positives and then the negatives on the other side, right? Does that make sense? It's half positive, half negatives, but they also add up to the same amount because it's a linear rate of change for the energy. Now, the only way in which it would be positive if they were if the linear rate of change when the kinetic energy is less than 1/2 is higher, I guess. Is that right? And then if it were lower, then that means you would get more components. Or is that wrong? Maybe it always adds up to 0. I don't know. I want to have to think about that one more. Yeah, I don't know. I keep seeing a lot of synchronicities. I don't know. I like Carl Jung and the synchronicities. I don't know what that means. It's reassuring to some degree. A lot of people say it's just a form of quote unquote coping. I think it's more than that, but well, I guess to some degree, reality stems from the mind's need to cope. But at the same time, there's a deeper truth behind it. It's not just that the mind is looking for it; it's that the universe, it's accepting the fact that the mind is looking for it. So it shows up more in reality. Now, I mean, that sounds crazy to some people, but I actually happen to believe it. Yeah, I'm gonna have to look at the main thing I want to look at is the Lagrangian and all that right now, and just because of path integrals and whatnot. And I had to look at Hermitian matrices still, and I had to look at a lot of GR stuff. I was actually looking at a video on GR, looking at the metric tensor, and then I was going to look at the Ricci curvature tensor as well, but I didn't have time for that. The metric tensor is easy to understand, but the Ricci curvature tensor is a little bit more complex, so I need a little bit more time to absorb that object. So, yeah, and I also wrote tensors in general because I understand them, but I also haven't played around with tensors to really understand what they mean, other than the fact that they are invariant under certain transformations in space and whatnot. These tensors have to, again, this is all under the laws of physics having to coincide, no matter the frame of reference, I guess, would be a good way to say it. That sounds very hand-wavy, but it's true, and these tensors tend to explain that and compact all the information in that manner. And I was looking at manifolds, and then I forgot to look at connectedness more, and I have a general understanding of connectedness and compactness, and I guess I kind of had to deal with, I don't know, I think we looked at compactness in real analysis. I vaguely remember that, but yeah, I mean, compactness, I don't know. I don't really have an amazing general definition of it. I can give a couple of examples, but I'm too lazy to even give a couple of examples right now. And this video is getting pretty long, and yeah, and I guess I was going to look at, the motivation behind general relativity as well as another thing I had to look at. And I also wrote down the field equation. They actually have a huge, would it be called a Merle? I think it's a Merle, and is it maybe in the Netherlands? I don't know. I was looking at the general relativity or the field equation page for the Wikipedia, or Einstein's. I think it's basically a Merle. I don't know. I actually don't know if it's in the Netherlands. It's in the Netherlands. I passed a trivia test. I used to downplay trivia, but it can be fun sometimes. So I have quite a bit. I still have a lot of studying to do. Research. I like to call it research. If I think of it as studying, then I feel like I'm a lowly student in a university somewhere that is dreading the whole indoctrination process. There we go. Oh my god, I sound like Chomsky or something. I don't know. I think he's talked about this kind of stuff before, or something close to it. A lot of little endeavors to go through since I'm a meander. I hope you guys have a wonderful day. Bye.